Hello, in this video we're going to discuss the angle measure, specifically in radian, and how it can be used to define sine, cosine, and tangent functions. So first, let's review the angle measure. Angle measure is a quantity that measures openness between angles to rays. So measuring this openness will give us an angle measure. So there are two different ways we can measure angles, using radian or degrees. In this video, we're going to specifically only focus on radian first, and then define sine, cosine, tangent function. Radian, a unit of an angle measure where 1 radian corresponds to an angle that cuts off an arc length equal to radius of the corresponding circle centered at vertex of the angle, or 1 over 2 pi of a circle's circumference. Equivalently, 1 radian corresponds to a rotation from the initial side to the terminal side of 1 over 2 pi of a complete rotation. So let's look at pictures right here. 1 radian means that this radius length and this arc length created by this angle are equal. So we have 1 radian. And same for this on the smaller circle on the right, we have 1 radius, and 1 radius length covers the arc length created by the angle. So therefore, both of this circle shows 1 radian angle. Putting in an equation, we can measure angles in radian by quote-unquote counting how many radius length we need to obtain the arc length. So generally, we write angle in radian equals arc length divided by the radius length. And when we're dividing by something, that means we want to see how much radius go into arc length. How many times can the radius length go into arc length? So for example, 2 pi radians is about 6.28 and is unending decimal, which is the circumference of a circle, is 2 pi. So that means the circumference of circle is 2 pi times as large as circle's radius length. That ratio is always true for any circle. Now how about 2 radian? Not 2 pi radian, 2 radian. 2 radian means that the arc length subtended by the angle is 2 times as large as the circle's radius. So I can quickly sketch this. So if I have a radius this length, then this arc length is 1 radian, here's 2 radian. So this angle right here represents 2 radian. 1 over 2 radians means the arc length subtended by the angle is 1 over 2 times as large as circle's radius. So for example, if I have radius of maybe 10 centimeter, the angle they created by this is that this arc length is now 5 centimeter. So now we have a half radian. This would be half radian. Which again, essentially we're just doing arc length divided by radius. That means how many times the arc length can go into, how many the radius length can go into the arc length, half times. Now with that in mind, the idea of radian, we're going to define a sine function. Before we look at the sine function, you'll notice that the way we define in this video is not using a right triangle. Rather, we're just using an angle, an x and y coordinate, or rectangular coordinate or Cartesian coordinate. The reason is that we want to think angle as a varying quantity. The function, when we say function, in this case sine function takes input quantity and outputs another quantity. So that means that it is important for us to think about the input quantity as a changing things. But if we only think as a right triangle, we define the sine, cosine function and tangent function as right triangle, it's hard for us to imagine how this angle changes in a given fixed triangle. So that's the motivation for us to define sine, cosine, and tangent function using just the angle input in radian, and we'll discuss what it means to have a sine function as an output. So sine function, y equals sine theta, relates the angle measure theta to the vertical height of the point above the horizontal diameter measured in radius length. So let me elaborate that. So first of all, what is saying that here, the horizontal diameter is right here of the circle. This horizontal diameter. And what sine function does is it takes this input right here, theta. So in this case, this angle, this is the input. And it outputs this distance right here. This distance from the horizontal diameter measured in radius length. That means we divide by the radius length. Radius is r. So that's what sine theta. So as you can see, there's no mention of a right triangle. We're just looking at an angle measure and its terminal ray and the distance between terminal ray and the horizontal diameter of a circle. So we measure this distance and divide by the radius. So let's look at it in more technical terms. The sine function for input theta in radian, sine theta represents the vertical distance measured in radii or radius length. That just means, again, divide by radius of the point on the circle above the horizontal diameter. In order to measure this distance in units of the radius length, we need to find the ratio of the vertical distance to the radius. Or if you look at this triangle, well, we form a triangle because of an angle, right? So it's not that we always think as we draw a triangle. If you look at this angle, here's an angle, theta, and here's a terminal ray. And here's this distance b. So theta, we know that if this is arc length, well, this is the arc length, right? This is the arc length. Theta in radian is arc length divided by r. And what sine will produce as an output is b, this length, divided by r. So if you look at right here, sine, again, this represents an angle in radian, which is arc length divided by radius. And the output is this vertical distance from horizontal diameter divided by r, radius length. So one benefit of thinking this way is that we can always think as angle as a varying quantity. We just don't have a fixed right triangle. We can see that this angle can now change. We can have another angle right here. Then in this case, we'll measure this distance, divide by radius. If we have an angle right here, then we'll measure this distance, measuring radius length, divide by this, and so forth. So this is why the angle in radian and the sine are related. As you can see, both are divided by radius length. How about the cosine function then? Cosine function represents the horizontal distance measured in radius length. So here's the input angle right here, theta. This is the input. And what the cosine measures is from the vertical diameter. In this case, now this is the vertical diameter. It measures horizontal distance, this distance right here, from the vertical diameter to the terminal ray, measured in radius length. So we do have to divide by the radius. So again, if you look at it in more technical terms, for input of theta, cosine theta represents horizontal distance measured in radii or radius length. Again, that means just divide by radius length of the point of the circle right of the vertical diameter. So the reason we say right of the diameter, because if it goes left, we think as its negative value. So similarly, this right here is an angle in radian, right? And output, now output is this horizontal distance, this distance, or we can also think it's their same distance, this one. So again, this is angle in radian, and output is the horizontal distance measured in radius length. And it's just similar to sine function, input also divided by radius, output also divides by radius. How about the tangent function then? Tangent function measures, so both sine function measured vertical distance, cosine function measured horizontal distance. What does tangent measure? Tangent function measures a slope. So it relates the angle theta to the slope of the terminal ray. So here we have a given angle right here, theta, and tangent will give a slope of this terminal ray, which is changing output divided by changing input, which is this distance divided by this distance. We commonly learn that tangent theta equals sine theta over cosine theta, which is true. It is sine theta over cosine theta. But another way, or maybe this way we should define the tangent function as its standalone function without relying on other two functions, is that it is slope, but way we find slope is vertical distance divided by horizontal distance, which is also sine theta divided by cosine theta. Because if this radius, if this is r, we know that sine is actually b over r, and cosine is a over r, which does simplify to b over a. So algebraically, yeah, we can see that they're the same thing. But another way of thinking of tangent function standalone as by itself is that tangent function measures slope of the terminal ray that created by the angle. And when we look at a unit circle, because unit circle has a radius of 1 and has center at 0, 0, the x, the horizontal distance represents cosine of that angle t in this case, and y represents sine t, the vertical distance. Because we divide by r, but r is 1, that's how we can say that x is cosine t, y is sine t. And if we look at the first quadrant of the unit circle, we have sine, cosine theta, comma sine theta. So let me rewrite here again. The x, comma y is same as cosine theta, comma sine theta. Again, this is because x represents horizontal distance, and horizontal distance in unit circle, we divide by 1, which is radius. That's what we get straight, just cosine theta. Similarly, y is the vertical distance, and because radius is 1, y divided by 1 is y, and we get sine theta. So the way we interpret this unit circle is that this half here means that this vertical distance from the horizontal diameter of a circle is half. So sine of pi over 6 gives us that distance. And this right here, let's look at cosine. This means that this angle right here, this angle, if this angle is input, the cosine gives us the output of this distance, horizontal distance from the vertical diameter of a circle, which is square root over 2. Again, the radius is 1, so divide by 1. So in summary, rather than always think about sine, cosine, tangent function from the right triangle, we can also think in terms of just a varying angle on a x and y coordinate. Not on a fixed right triangle, rather on a circle where we can always point out different measure of angles. Cosine theta represents the horizontal distance from the vertical diameter of circle to terminal ray. Sine theta represents vertical distance from horizontal diameter of a circle to the terminal ray. And tangent function represents slope of this terminal ray when this is the input. Thank you.